Hey guys, and welcome back to Math Pastor. Today we're going to begin a new series called Linear Functions. Hey, in the first part of this series called Linear Functions, we're going to talk about relations and functions. If we're going to talk about what linear functions are, we should have a pretty good idea about what functions in general are. So today we're going to define a few terms to make sure we're all on the same page, and then talk about some of the math problems you might see when it comes to relations and functions. All right, so the first term we're going to discuss is relation. All right, in algebra, a relation is just a set of ordered pairs. Now, that sounds really technical, but an ordered pair is just two numbers put together. So the first value and the second value, often these are written as coordinates. So you might have a number, comma, a number in a set of parentheses. These numbers could be written as part of a table. So the first column running up and down could be your first values, and your second column running vertically is your second value, and every row is an ordered pair. Or you could have what's called mapping. A mapping is when you see all of the numbers that are your first coordinate in one group, and all of your numbers that are your second coordinate in a second group, and then you have an arrow showing which number in the first group goes to which number in the second group. And we'll talk more about that in just a little bit. But a relation is just a set of all ordered pairs. So those numbers could be predictable, they might be unpredictable, but those numbers are numbers that go together. So the first number and the second number are a set, they go together. Every element in the first set is part of what we call the domain, D-O-M-A-I-N, the domain. And that's all the first values. So the collection of all of the first values is called the domain. The second value is called the range, R-A-N-G-E, the range. So the domain goes to the range. That's how it works. And the domain is the set of all input values. So sometimes people will call them inputs, sometimes people will call them domain. And the range are called output values. So your collection of all of your inputs is called your domain. The collection of all of your outputs is called your range. Now, oftentimes, input values are what math is being done to. So you're multiplying, you're adding, you're subtracting, you're dividing, whatever you're doing, whatever math you're doing is done to the input value. The output is your result or your answer. So oftentimes, your domain is what math is being done to, and your range is the answer to that math problem. And that's usually what your domain and range are, also called your inputs and your outputs. All right, there's a special type of relation called a function. A function is when all of your inputs go predictably to only one output. Now, when we see a math rule, so when you see math being done to the input and it gets you an answer that's the output, usually that's a function. Now, we'll talk more about that in a moment, but a function is just when, and the definition is this, in a relation, when the input goes to exactly one output, or your domains all go to exactly one range. So, another way to think about this is a relation would not be a function, not be a function if any of the input values repeat. So if 2 is the first value in a coordinate and 4 is the second value, but then later on you see 2 is another input value, but it goes to a different output value, so 2 also goes to 7, well then that's not a function because there's not one unique answer for the input of 2. It goes to multiple answers. So for a relation to be a function, your inputs must go to only one output. Your domain must only go to one range. Your value that you're doing math to must get a single answer, and that's it. If it goes to more than one output or more than one range, then we say that relation is not a function. All right, so there are 4 major ways that you can see if a relation is a function. The first way you'll be given information is as coordinates. And check this out. You could be given the coordinates, ready? Here they are. -1, 1, then 2, 0, then 3, 1, then 3, 2, then 4, 5. So we have 5 coordinates written down here. Now all of these are fine except the input of 3. If you notice, 3 goes to 1, but it also goes to 2. So since the input goes to 2 different values, this relation is not a function. So remember, a function can only go to one value, but since 3 goes to 1 and 3 goes to 2, this is not a function. All right, the second way you can see whether a relation is a function is using a table. So if you see a table, the first column or the left column is going to be all of your inputs or your domain. The second column or your right column going up and down is going to be your range. So if you see your domain and your range, all you have to look to see is your column that is your domain, do any of those values repeat? If they do repeat, then it is not a function. So here's an example. Using the numbers we had before. In the left column, the inputs would be -1, 2, 3, 3 again, and 4. The right column, which is your range, would be 1, 0, 1, 2, and 5. So as we can see here, the values in our first column, 3 occurs twice. And since it occurs twice but goes to 2 different values, this is not a function. The third way you could see this given to you is a mapping diagram. Now, a mapping diagram has all of your domains in one circle or collection, and your range in a separate section or collection. So, all of your range is over here, and all of your domain is over here, and domain goes to range, and you can see what goes to what. Well, check this out. If in your domain, any of your values in your domain, any of your inputs, if they go to more than one value, not a function. Not a function. So here we have these values. In our domain or our inputs, we have -1, 2, 3, and 4. In our outputs, we have 0, 1, 2, and 5. I've simply put them in numerical order, but now I'm going to draw arrows to what input goes to which output. So, -1, I'm going to draw an arrow to 1. 2, I'm going to draw an arrow to 0. 3, I'm going to draw an arrow to 1 and a second arrow to 2. And then 4, I'm going to draw an arrow to 5. So if you look at the input bubble, you can see that 3 goes to 2 values. And again, that means this is not a function. The fourth way you can look at a function is using a graph. Now, when you look at a graph, it might be a graph of points, it might be a graph of a curve, it might be a graph of a line. Well, whatever the graph is, whether it's points, a line, or a curve, all you have to look to see is, does any vertical line, vertical meaning straight up and down, does any vertical line touch this graph or points at more than one spot? So if a vertical line touches the graph or more than one point, then it is not a function. Because remember, the horizontal axis is your inputs, the vertical axis is your outputs. So if there's a value on your x-axis or your horizontal axis that goes to more than one vertical point, that means your input goes to more than one output. And if that's the case, then it's not a function. So we call this the vertical line test. So if you take a vertical line and you run it along left to right of your graph, if that vertical line touches more than one point, then it fails the vertical line test, and that graph does not represent a function. All right, so here we have an XY plane already set up. Our horizontal or left to right axis is our x-axis. Our vertical or up and down axis is our y-axis. And when we graph points, remember, you go left, right from the origin where they cross. You go left, right first, and up and down second, then make your dot. So if we look at our 5 points we've been looking at so far, the first point is -1, 1. So from the origin, I'm going to move left 1, up 1, and make a dot. There's my first point. The second point is 2, 0. So from the origin, I'm going to move right 2 units, and I'm not going to move up and down at all because 0 means don't move. The third point is 3, 1. So I'm going to move right 3, up 1, and make my third dot. My fourth point is 3, 2. So I'm going to move right 3 again, up 2, and make another dot. And my final dot is 4, 5. So from the origin, move right 4 units, up 5 units, make a dot. So here are the 5 points that are a relation. But are they a function? Well, check this out. We just have to look at the vertical lines and see if any 2 points are on the same vertical line. And if you imagine a vertical line going through the x-axis at 3, you can see that there's 2 red dots right there. And since there's 2 on the same vertical line, then this does not represent a function. All right, guys, so you should be all set to answer any questions that deal with domain, range, which is also input, output, function, and relation. Remember, when you're asked to identify the domain and range, all you're doing is writing down the first coordinates for the domain. So domain, and then write down all those coordinates. And range, write down all the second coordinates. That's all it's asking you to do. Domain and range. What goes in as inputs and what comes out as outputs. All right, guys, till next time.